Welcome to another Test Subjects Tech Tips. Today we're talking about hacking. And I don't mean the movie from the 90s, and I don't mean computer coding or anything like that. I'm talking about how do you hack a prop to be hardwired to a pre-existing prop or not run on battery power, or if it's going to run on battery power, how do you change the voltage from one to another? Now, there are two types of power you're going to be dealing with, the pretty typical AC and DC. And of course, DC is generally battery powered, AC comes out of your wall, but those are not hard, fast rules. But for this sake, that's how we're going to talk about it. So let's go over the simple one first, the battery powered, right? So I have here a little thing that I pulled out of a candle. This used to be part of a fake candle here. This runs off of batteries, as you can see here. And one of the things that's very important is to know what voltage something runs off of. In this case, these are 1.5 because these are AA batteries. And that means that this whole device runs off of 3 volts. So you're going to need a 3-volt power supply or something to drop it down to 3 volts from a larger voltage, which we'll talk about later. So as you can see here, when I turn this on, the LED lights up. So that is, that's the basics of it right there. And just about any battery-powered thing will work this way. You'll usually have a switch of some sorts, and it'll be running to some sort of circuit board, and obviously the batteries vary in size and also voltage. If you had 4 of these, that would be 6 volts. If you had 3 of these, that would be 4.525 volts. There's generally circuitry that'll kind of fudge the voltage a bit to help with smoothing out any issues. So how do we get this to work with wired voltage if we wanted to plug this into the wall and not have to switch out batteries every day? Well, this one's pretty easy. Some of them are a lot more complicated, but this one itself is fairly simple to figure out. And the reason for that is here on the circuit board, it's already printed with ground and positive VDD. Sometimes it'll say VCC, sometimes it'll just be a plus and a minus, either way. It's not always this simple to tell, and so sometimes you have to look at the battery terminals here and where these things end on the inside. So you'll notice here you have a wire running from this terminal and you have a wire running from this terminal here, like this. Now obviously this one's going to ground, but the way you can tell that is generally with the way the batteries go, right? So the nubbin part here is positive, the flat side is negative. And so you'll notice if the wire is coming out here, and usually the negative end is the spring end right here where that is. That's generally the negative end. Not always, but usually. So you can kind of look at that and go, okay, well there's a wire coming out of there, so that's negative. And then if you look here, the same thing. There's the nubbin there on the top, and that's connected to this, so that means that's our positive right here. So that's pretty easy to deal with. So if we were wanting to get rid of these batteries and use something else, all we have to do in this case is break these wires off. Like we don't need the switch because hopefully our room controller or whatever will control that. So I just have to kind of wiggle this off of here and break that off from there. And I could use scissors, but this is more fun. Wiggle, wiggle, wiggle. Anyway, so in this situation, this is the, that's it. That's all you need to do right there. So let's strip these wires back a bit like this. Here we go. We're gonna just cut those using my little dinosaur stripper. Rawr! Right there. And now all we have to do is hook up for, in this case, to show you kind of what's going on, is we're gonna use these alligator clips here to attach this to here like that. And I have a power supply over here that I'll grab. Hold on a second. So I have here a 3-volt power supply, and I'm just gonna plug this into here like this, and boom, and boom, and now there you go. This lights up because this is being hardwired into 3 volts. And that is how easy it is to change some sort of battery-powered device into a wall-powered device. And now I'll show you what to do if you don't have a 3-volt power supply, or you're using something with a lot higher voltage and you need to drop it down. All right, so what I have here is called a buck converter or voltage converter, something like that, but I think this one specifically is called a buck converter right here. And so what this does is this takes a voltage that's coming in and changes it to a different voltage coming out. And there are all sorts of different types of these. There are tiny little voltage regulators that you can put on a breadboard. There are little voltage regulators that are little boards that are already at the proper voltage, and those come in all sorts of shapes and sizes. There are ones of these that do not have a digital display readout. You have to use a multimeter to know where the voltage is and stuff like that. So there are a ton of different ways to drop voltage down. You could even use resistors and do a voltage divider circuit if that's your jam. There's a lot of different ways to do this. These are the kind I prefer because they're very easy, no fuss, no muss. So I will show you how these work using a 12 volt, actually I take that back, this is a 6 volt power supply right here, right? So I'm gonna plug this in and you'll see here that this reads out, it's giving me 5.7 volts out right there. If I switch this over, it shows me the in, which is 6.3. So that is what I am looking at right there. Let me turn that this way so you can kind of see that a little better. So you can see here that that is 5.7. So how do you change that? There's a little tiny potentiometer, a little screw here. And some of these have buttons you can adjust the voltage with instead of using this, but I don't mind using this here. So I'm going to rotate this. I'm doing this counterclockwise like this, and sometimes it takes a while. Sometimes it takes a while for the thing to kind of kick in and go, oh, hey, you're trying to drop the voltage down. So don't fret sometimes if it doesn't happen fast. Sometimes you just have to take a little while. So you'll notice here as I turn this, the voltage starts to drop. You can see now it says 3.8. And so, too much. There we go. And we'll get this right at, 3.1. It's fine. This can handle 3.1 voltage. It doesn't have to be right at, okay? So again, we have 6 volts going in, and now we have 3 volts coming out. So if I was to hook this up to here like this, that will give us 3 volts. And there is our LED lit up just like before. So that is how you can turn a battery-powered thing into a non-battery powered thing. It's pretty easy, as you can see. It's not rocket surgery, as it were. Now we're going to go into the little more involved version that uses AC voltage coming out of your wall. So almost everything you plug into your wall with a power converter is converting AC, 110, 210, whatever your voltage is, down to DC. Now, that's not always true. Sometimes it's converting AC to AC as well. So always want to check the power supply. But when I say power supply, I mean these little wall warts, these guys here, right? These are what most of things run off of in different countries. And they will always tell you what's going on, well, always. They will usually tell you what's going on right here. This one in particular, it says input 100 to 240 volts, 50 to 60 hertz, 0.1 amps. Output 5 volts at approximately 500 milliamps, right? So that's basically what's coming out of this. If you were to crack this open, on the inside, you would find a voltage converter, similar to what we saw earlier in the video, something that is dropping the voltage down to a different voltage entirely. And so what that looks like generally is something like this little thing here. This is a voltage converter transformer is probably the more common term you would hear. But there's a transformer inside of this that is converting the voltage here. And this one in particular comes out of this. This is one of those flame light bulbs that you see that simulates fire coming off of stuff, right? And now this screws into your wall, into a lamp or whatever, and this is what takes the 110 voltage. But if you were to crack this open on the inside, which I have already done, as you can see, you will notice that you would find this inside of there, or something like it. And generally generally these are labeled, but not always. So I'll give you an example. Like this one here you don't know which way is in or out. You can kind of tell by looking at the components on here. But if you're lucky, what'll happen is you'll get one like this that will actually say in or out. This one has out listed on the bottom. This says in, and there's an arrow pointing this way to show the flow of electricity. So that is generally what you'll find in here. This is a little tiny one. This is a slightly larger one, and the larger you go, the bigger they become, like that. So this is how you find out what voltage to use in something like this. If you wanted to convert this to a lower voltage, as an example, I have used these to make handheld torches for an escape room before, and other things that use battery power, right? So you have to find ones that have the right voltage that you need, as well as the right battery life and everything like that. But you could also just hardwire these. I've also hardwired torches to walls and things like that, and so I'll show you how to do that. The first thing you're going to need is a multimeter here. This is the handy dandy one that I have here, like this, and I'm going to turn this to DC voltage here, my 20, like that. So now, the other thing you're going to need is some alligator clips like we had earlier, like this. We don't need this anymore. The other thing you're going to need, and I cannot stress this enough, if you do not feel comfortable with messing with AC power, then do not do it. If you have any doubts in your ability or the setup, leave it alone. Have somebody else do it, find somebody who's comfortable or a professional to do it. It is generally pretty safe, but there's no reason for you to put yourself in harm's way. So let's just put it that way right now. I've already kind of done that on this one here. This one, like I said, does not have an in and out listed, but I've already figured out where the in and out was on it. If yours doesn't have that, and again, you're not comfortable figuring it out, maybe don't mess with it. But I've already drawn an arrow showing which way the voltage is going. So this is my in over here with the larger capacitor. This is my out over here. And so what I'm going to do is I'm going to plug in a cable into an extension cord over here, which will be putting out 110 voltage. And I'll show you how to kind of do that safely. Hold on a second. So this is now running 110 out of it right here. And I have marked on the cable what the black is. It's the negative, so I know. I'm trying to be very safe here. And I have don't leave the wires bare so they can't touch and short circuit anything. I've got them on this lever nut thing here, so I am a little more safe here. So I'm going to take this converter and I'm going to attach this in, ground first, just to be safe. Like that. We'll connect that there. And now I'm going to connect this into there. And I heard a pop, which I know it is getting power and voltage right now. So let's, hold on, I'm gonna keep that from moving. There we go. So now the next thing to do is to see what the voltage coming out of here is. So I know this is DC voltage, so it's okay if I touch it. I wouldn't put both fingers on it just in case. So now I'm going to run this to my multimeter, and this will tell me what voltage I'm getting. This is outputting from 110 to 4.65. That's the voltage I'm getting. So that is 5 volts. We're going to round up it's okay. Like I said, most everything has a little bit of circuitry and a gray zone to handle voltage fluctuations. Going from 4.65 to 5 is not going to damage anything in the long run. So I now know that this is outputting 5 volts. I have encountered other things, other types of light bulbs that output 14 volts, 7 volts, all that stuff. But this is how you determine what the voltage you need to convert it to something else. So now that we've done that, we know what we're dealing with, we can power this light bulb. All right, so we know that this requires 4-ish to 5 volts. So I can take my plug here and plug it in like this, and you see it lights up there. I'm gonna get it to go to the flame bulb option there, because these for some reason have some sort of weird toggle thing with 3 different modes. I don't know why, but they do. But that is essentially, now this doesn't work with incandescent light bulbs. That's not how that works. This is LEDs on the inside. So if you have LED light bulbs, you likely have a transformer inside of these, and you can convert those over from 110. But in a situation like this allows you to wire up a bulb like this to your main control system and not have to worry about how to switch 110 voltage and things like that. You just have to worry about converting voltage. Let's say you're using a Fright Props controller that runs 12 to 24 volts, and so you need to drop it down using one of those converters or something like that. That's how you hack your way into something like this. And so now you know how to convert 110 AC and low voltage DC battery powered. You can go forth and make cool new stuff. Hey guys, make sure you check out some of these other videos we have here. And of course, if you want to keep up with anything we're doing, make sure you subscribe, click the bell, and make sure you also check out testsubjects.com for more info. And if you have something very specific you want us to go over, please let us know in the comments below. See you next time.